This system is primarily required to keep the engine cool and at its optimal operating temperature. It is located directly within and around the engine. You can see the key components of the cooling system. Let's review the liquid cooling system in detail, via cylinder block ducts and cylinder head ducts. These ducts, known as the cooling jacket, are filled with coolant. The cooling jacket is situated around the engine cylinders and serves the primary purpose of removing heat from those cylinders. The coolant doesn't stay in the same place. Instead, a water pump keeps it circulating in a closed loop. In turn, the pump is normally rotated by a belt drive that is powered by the crankshaft. This type of pump is known as a centrifugal pump. The liquid would be cooled too slowly in this setup, causing the engine to overheat. Therefore, the radiator cools liquid through a high-efficiency heat exchange process. The radiator is made up of two tanks with an inlet pipe for heated liquid and an outlet pipe for a cooled liquid. The tanks are linked together by a system of tubes. Fins are added to the tubes to improve heat transfer capacity. These systems are referred to collectively as the radiator core. A drain valve is normally located near the bottom of the radiator. The radiator is also equipped with one or more fans that boost the flow of the air traveling through the radiator in case the system fails to cool the liquid to the proper temperature. When a specific temperature is surpassed, the fan is turned on using the radiator coolant fan switch, or more commonly, the engine coolant temperature sensor. The sensor also displays the current coolant temperature to the driver on the dashboard. Typically, the sensor is positioned near the engine coolant outlet. It should be noted that the cooling system is a sealed system. When the coolant is heated, it expands, causing the pressure in the system to rise. This is required to raise the coolant's boiling point. However, excess pressure must be released to prevent system harm. One of the ways to do it is to use a special pressure cap on the radiator. When the maximum allowable pressure is exceeded, the cap opens, enabling coolant to escape into the expansion tank. When the pressure decreases, the liquid is pulled back into the system. This design excludes pressure in the expansion tank. The tank stores a coolant supply and has free space for liquid expansion. The expansion tank also features coolant level indicators and can be used to refill coolant as needed. This is another design with no radiator cap. Pressure relief is provided in this case by the expansion tank cap, which manages the pressure level in the system in a similar manner by releasing and sucking air. This system is already capable of cooling the engine. However, due to the continuous passage through the radiator, it will take a long time to heat the coolant in this instance, and maintaining the appropriate working temperature will be a problem. This will result in increased engine wear and excessive fuel consumption. To prevent this, the system is equipped with a thermostat. The thermostat divides the system into two circuits, a longer one that uses the radiator, and a shorter one where the radiator is bypassed. When the coolant temperature is low, it will circulate around the shorter circuit bypassing the radiator, thus allowing the engine to reach operating temperature more quickly. When the temperature hits 82 degrees centigrade, the thermostat valve gradually opens, and the hot liquid mixes up with the radiator-cooled liquid from the longer circuit, which ensures that the temperature is balanced. If such mixing is insufficient, and the temperature continues to increase. At 93 degrees centigrade, the thermostat will shut off the shorter circuit and fully open the longer circuit, allowing the entire volume of the coolant to circulate through the radiator. You can now see a fully operational cooling system. However, it is missing one critical component the car can't do without. It is the heater core. In this layout, the heater core is integrated into the cooling system separately from the thermostat. The heater core harnesses the heat from the coolant to heat the vehicle's cabin. The cooling system is now complete. There are other, more complicated layouts. They may contain two thermostats, electronically controlled thermostats, as well as more complex cooling circuits that keep the EGR system, turbocharger, throttle, intake manifold, and automatic gearbox oil at the appropriate temperature.